Thanks everybody for joining us. Greatly appreciate it. Today we're gonna be covering about getting started with Eagle. I wanted to make this webinar going from A to Z, so that's why it's intended to be a little bit on the a little longer than usual. So we'll go ahead and begin. First of all, my name is Edwin Robledo. I'm support specialist for Autodesk Eagle. And Jorge and myself, we are located here in South Florida.
Yeah, so I've been actually working with Eagle since I was in college, way before I worked here. I actually got support from Ed. I don't even think you remember that I called him.
I think I do. I think I do. Yeah,
But
you're using the light version. We called it back in those
right,
times. Yeah, we
I was
called it
in
the light version.
version 5 at that point. And you know, one thing to another, and I ended up here. You know, and I enjoy engineering. I enjoy helping users, and it's been fun. I've been here almost 10 years, almost
Wow, excellent. Thank you.
getting there.
Yeah, so we're both here located in South Florida. We're going to be talking about Eagle and the board layout editor and the schematic editor. But I just wanted to let you know that Eagle basically consists of a platform of multiple editors within the same design space. We have the schematic editor, which is basically a logical representation of your design, of your schematic. We also have the board layout editor, which is actually working with the physical aspects of your circuit board. What you see is what you get. Okay, so the way it looks on the circuit board is actually what you're going to get back from the manufacturing or from the prototype house. And last but not least, and we're not going to be talking about this today, is the PCB library editor, which has its own portion of editors within itself as well. We're mainly going to be working on the schematic as well as the circuit board editor, and we'll be also doing some manufacturing files. On the schematic editor, in essence, basically what you do is that you're going to create a brand new project from the control panel. You're going to be navigating our libraries, selecting the components that you're going to be using, actually placing them on the schematic editor, and defining your connections. I did a little GIF file there. That way you could see more or less what's that workflow sort of look like. But Jorge is going to be going into this in much more detail. The second part, that will be followed by the board layout editor. On the board layout editor, what we're going to be doing is that we're going to be converting that schematic into the board layout editor. Now the board is not going to be laid out for you. Everything is going to be set off the side. Now what you're going to be doing is that you're going to start moving all of your components into the board layout editor. Now the connections will be transferred over from the schematic into the board. So you're doing fine there. In this example on the GIF file that I use here, I'm actually importing a Fusion 360 PCB outline that was actually created by somebody else in Fusion 360, and I imported that board outline. That way I could use the exact same environment that they're going to be using for the circuit board. So I actually imported that from Fusion 360. We'll do some manual placement and some manual routing. We might have some time to play a little bit with the auto router. I think we might have some time for that. And also we'll do some slight definitions of the design rule checker, like clearance. How does clearance affect your auto router as well as your manual routing capabilities, okay? Then finally, I just wanted to let you know that Eagle actually has what's called real-time forward and back annotation. What that means is that any modifications done to the schematic actually update the circuit board, okay? So when you delete a portion of your board, of your schematic, it actually gets deleted from the board layout. If you delete connections on the schematic, that actually affects the board. If you rename components or rename signals on the circuit board, that actually updates the schematic. And you'll notice that you have like a thunderbolt on the bottom right hand corner of each editor. In this case, it's right there. Let me see if I can point it with my mouse. It's right there, that little thunderbolt right there. If that's green, you're doing fine. If that ever turns red, stop. Stop whatever you're doing, you need to stop, okay? And I have a really good YouTube video on our YouTube channel in which says that if you've lost consistency between board and schematic, what steps you should do. Now I have a YouTube video on that already on our YouTube channel. So go to our YouTube channel. That way you could find how to get consistency back. So if that ever turns red, you stop whatever you're doing and we'll recover from there, okay? Now, the final stage, what we're going to do today is that we're going to cover how to create your manufacturing data. The most common formats that we use is Gerber 274X. We do support X2 format as well, and how to generate your drill files. There's a couple of ways of doing this. There's a real easy way, which does everything for you, or you could actually go through the CAM processor and go through the stages, and we'll do our best to do both of them today. Okay, so you know what? I'm going to pass the ball over to you, Jorge, because I think it's a good time for you to do your demonstration.
So here we have, let me change this, something else. Let's go ahead and get started. This is the Eagle control panel. Since we're going A to Z, I'm going to take like 2 minutes on the control panel. It's going to be, Ed, you stop me if I miss something, but I'm going to be moving.
Okay.
So basically in the control panel, especially in the newer versions of Eagle, we've created a separation between the stuff that ships with Eagle, the examples, the UOPs that ship with Eagle, your user files. So by default, every one of these trees has 2 folders. The first one is your user stuff. The second one is going to be whatever you own. Now, right off the bat, the second one's going to be whatever ships with Eagle. Now, right off the bat, there's a discrepancy in the libraries tree. The first folder is any local unmanaged libraries that belong to you. The second folder is managed libraries. Now, these include everything that ships with Eagle and your personal managed libraries. Okay, so that's the only exception. So under the libraries tree, the first folder is your personal libraries that you haven't managed. In the second folder, managed libraries, you're going to see my managed libraries. Those are your personal managed libraries. And we're not going to go into too much detail with managed libraries today, but that's just something I wanted to highlight. Everything that ships with Eagle, you'll find here under managed libraries. You can't edit any of the libraries that ship with Eagle, but you can copy from them and use them as source material for your own libraries.
Yeah, the only thing I like to mention about the managed library is that you could access them remotely from any other computer when your library is managed.
Correct. Once the library is managed, you can go anywhere, any computer, sign into Eagle, and you can download your own personal libraries from there. So that's a big advantage that it has. Okay, design blocks. Design blocks, again, you have your personal design blocks, and you have the ones that ship with Eagle. I have a few personal design blocks myself. So the way design blocks work is that these are reusable circuits. So if you have a regulator that you tend to always like to use, or if your company has products that are all basically variations of the same initial design, that's a good candidate for a design block. Basically, you can do just a schematic, you can do the board, or what I find to be really useful is the schematic and the board together. You basically treat them as a component. Now, this link is very, let's say, very soft. Once you place these into your design, then Eagle treats them as if they had been drawn, from the beginning. They're no longer treated as a block. So they're good for design reuse. They're good for pieces of design that you constantly have. So if like you're an audio designer, for example, and you make effects, you have the same switches, the same switch layout for all of your effects or whatever, then that's a good candidate for a design block. So again, Eagle comes with several examples, and you can see those and play with those at your leisure. Design rules. Design rules basically check that the board file is manufacturable. So you want to set up your design rules to match whatever your board house can do. Eagle ships with the default set, which is default.dru. It is very conservative by default. So what that means is that it requires bigger clearances, larger holes than most board houses today really need. Most board houses can do much finer features. So the idea behind the default DRU is just to make sure that pretty much anyone can make the board and not have any issue. If you have the default DRU and you see that you get some design rule errors, what doesn't necessarily mean anything is wrong. It just means that you haven't set it up to conform to what your board house can do. Once you set it up to conform to what the board house can do, then any errors that pop up are legitimate. So the default is just really conservative. If it passes the default, then you know that you're not going to have any problems anywhere.
Yeah, the only thing I like to mention also on the DRU, on the DR design rule check, is that's where you're going to set up your layer stack up. So if you're going to be using 2 layers, usually that's our default. You don't have to touch, you don't have to go there. But if you're going to be working with more than 2 layers, you're going to be going to DRC to set that up. Just want to mention that up.
Mm-hmm. And then in examples, as you notice, we have from several manufacturers, and we're adding all the time. User language programs. I'm going to talk about these two together, user language programs and scripts. Eagle can be scripted. If you have any familiarity with C or with Arduino programming, you're going to feel pretty at home with this. Okay? Everything is documented in the help under the UOP section. So user language, you'll find all of the information you need there. There's also a lot of UOPs that ship with Eagle. Last time I checked, it's a few hundred, I think. 100 and something.
Yeah.
Something like that.
Yeah, some yeah.
100 and something. Sorry, it's a few hundred libraries that ship with Eagle, but UOPs is a few hundred. Okay, and we get a lot done through these. So these, on their own, they can't manipulate design data. They can extract any information you may have in your design, but they can't modify anything on their own. And that's where scripts come in. Scripts are just,
yeah. The honorary mention I like about this. Yeah, finish the scripts and then I'll give the summary I want to give. Yeah, I'll talk about that summary.
So scripts are very, very straightforward. They're just Eagle commands one by one in a file, and Eagle processes them as such. So it basically opens up the script, reads line 1, does whatever line 1 says to do, goes to line 2, so on and so forth until it finishes. So scripts are the movers in Eagle, or the automatic movers.
It's like if you were typing your command one at a time.
Correct, because for those of you who are new to Eagle, Eagle does have a command line. It's extremely powerful, and there's a lot you can do with it. And scripts are basically an extension of that. So the two very much work together. User language programs are the brains, scripts are the movers. Ed.
Yeah, I just wanted to mention one nice combination that we have is if you already have an Eagle design, we have a UOP that will actually generate your library based on your design, and that UOP actually creates a script file. That way it relates all of that the data in the new library to the actual design. So there you see that whole 360 workflow of the UOP creating the library and then having the script generate the relationship between the library and the design itself. Just wanted to mention that, how they interact.
So while we're here, the only thing I want to mention, there's only one script that I want to mention, that's the eagle.scr, and the only reason I'm mentioning it is because it is possibly the best way to set up defaults in Eagle. Every install of Eagle expects that file to be there. So anything you write to it, every install of Eagle automatically picks up. So we're not going to go into details today in it, but just be aware of its existence. It is an extremely powerful configuration script, and if you ever want to set anything up as a default, that's the best way to do it, eagle.scr. And there's a few example scripts you can see here that do other automatic things. We generally resort to these to restore Eagle to a known state, get the default colors back, the default shortcuts, things like that. Okay, so now we pass to the CAM jobs. CAM jobs are the mechanism that we use in Eagle to generate manufacturing data, to make Gerbers, to make the drill files. So again, we ship with several by default. You can install your own. You have a user section. The example ones are the ones that have always shipped with Eagle. So these are the ones that have been with Eagle for the last 10, 20 years.
Or more.
Or more. And then internally, the CAM also has a few templates that you can leverage. Spice models, again, Eagle now, for those of you who don't know, Eagle has a built-in Spice engine based on ngSpice. You can have your own, as well as the example models that ship with Eagle. All of the standard basic stuff is in Eagle. You can always get Spice models from the manufacturers. And then finally, projects. Now, my projects tree is a little bit different than what you're going to see when you default. When you default with the projects tree, you're going to have the examples folder, and then you're going to have your own personal projects folder. For me, I've gone ahead and just included the entirety of the Eagle folder. That's kind of the way I like to have it for me. But this examples is the normal examples folder, and these are all the examples that ship with Eagle. So, Ed, anything you want to cover in the control panel? Move on to the schematic?
Move on.
Question?
Nope.
All right, off we go. So now here under projects. I'm going to go ahead and right click, new project, getting started. Today is 12/11/2018. I press enter. It'll sort alphabetically. Now I right click on that project. Now one thing you want to notice is that there's a little green dot here, whereas all the other projects have gray dots. Green means it's the active project. It's the one that is currently going to be open and the one that all the actions are going to go to. So I'll right click on it. I'll click new schematic. Okay, so here we have the schematic editor. Get used to its appearance. The other editors pretty much look the same way with slight variations. So what we're going to do here is we're going to go ahead and start adding parts. You'll notice that we have 0, 0 right here. The origin is not movable. One thing that I want to emphasize for the schematic, notice this grid. It is 0.1 inches. If you prefer the metric system, go to here and change the units to millimeters, but do not change the value. Okay, on the schematic, it is critical that you stick to a 0.1 inch grid. Okay, for schematics only. On the board, use whatever grid is convenient, but on the schematic, you want to stick to a 0.1 inch grid because that's going to make it easy to have all your connections be made properly and line up. If you deviate from a 0.1 inch grid, you'll probably find that you run into issues getting things to connect properly. So that is rule number 1 of the schematic. Do not deviate from 0.1 inch grid. Now there are occasions, like if you're moving text around, that you may want a finer grid. That's okay. And as you're getting experience with Eagle, you'll know when you can do that. But for now, it's just a lot easier and safer to say, leave that alone. Don't touch it. Okay, 0.1 inch grid on the schematic editor. Very important, 0.1 inch grid. Okay, so let's go ahead and add components to our schematic. You notice all the libraries that are in use by default. If for whatever reason you start Eagle and you don't see the libraries, it just means your libraries are turned off. They're basically not active. And the solution to that, the easiest solution, is to go to the command line. You type the word use, a space, and then asterisk, and hit enter. And that'll make sure all your libraries get put into use. Okay? On rare occasions, for some reason, the libraries get unused.
Now, when you have all of your libraries in use and you do the add command, sometimes it just takes a few extra seconds to load the add
Correct.
box. It might just take a couple seconds because it's kind of indexing it.
Right. The first time you
Only
hit
the
the add
first
command,
Only the first
it'll
time.
be indexing, so it may take a few seconds to open. After that, it'll be almost instant every time. Okay, so that's during your session of Eagle. So as you can see, we have a lot of components in our library. We have a lot of libraries. And what I want to go over right now is just a search mechanism. And one thing you want to keep in mind with Eagle Search is that it is not Google. Okay, when Google, you'll type in a search string, and if you're more or less in the ballpark of what you're looking for, Google gives you pretty relevant results, you know. That's not the case with Eagle. Eagle is an exact match for the search. So if you're off by even a letter or a number relative to what's in Eagle's libraries, you're not going to get a result. So let's show you how to properly use the search. And we're going to do it by way of example. So let's say I'm going to look for the LM555 timer. Okay, very common part, old as dirt. I hit enter. Eagle tells me, sorry, no match. Now, in general, that'll freak everybody out because the 555 timer, like, you don't have the 555 timer, what do you have?
It's not like having water, something like that.
Yeah. So basically what ends up happening is to get around this or to make the search more flexible, you have to use wildcard characters. In Eagle, we support 2. One is the question mark, the other one is the asterisk, and they're all described here. Okay, so what I'm about to say is here, in case you ever forget it. So if you use a question mark, basically that's a wildcard for a single character. So if the search finds LM555 followed by a letter, a number, whatever, by one character, that may be a valid result. So I'll hit enter, and we'll see that we get now some results. We have in the Adafruit library, the D in the end, which explains why I didn't get any results before. because I didn't specify the suffix. You can also find it in the linear library. The linear library is the one that ships with Eagle, and you'll notice that it has 3D parts already mapped to it, which that's a conversation for another day. But in general, if you can get something with a 3D part already associated to it, that's going to be in your best interest. Now, we can generalize this further. If I put an asterisk in the front, what that means is it doesn't matter what's in the front. It could be 10 letters, could be 1, could be 2, could be however. It's an arbitrary number of characters. As long as 555 is somewhere in the middle and it ends with one character of whatever type, then that's a valid result. Okay, and you can see here that, again, now it's a little bit more flexible. We're getting more results. Obviously, we're getting some results that don't make sense, like this one here. It's not too helpful. We have a demultiplexer, which is definitely not what we're interested in, but it popped up. Okay, but again, the part we wanted does show up here, along with the other different prefixes that are available. So finally, just to complete the exercise, the most general search is if I swap out that question mark with an asterisk. At this point, this is as general as it becomes. Basically, if 555 shows up anywhere in the device name or in the description, doesn't matter where, that's a valid result. Kick it back to me. I want to check it out. And you can see now we get a whole bunch of stuff. And again, not all of it applies. Okay, so that's how you do the searches in Eagle. From least flexible, where you don't have any wildcards, to most flexible, which would generally involve multiple asterisks in your search string. Okay, so with that, let's go ahead and bring in the part that we want to use. I'm going to bring in the surface mount one. Okay, and you'll notice it's floating on my mouse cursor. I can left click to place it. If anybody finds the highlighting weird, it's just because I have high contrast mode on. Again, I'm not going to go into it in this webinar, but you do have full control over the highlighting in Eagle. So I'll place one. Now notice that the add command stays active. I can keep placing parts. Okay, and this is really useful because you don't have to cancel or reselect the add command. You can just add as many timers as you need, add as many resistors, as many of whatever you need, just put them in. Then you can hit escape, find the next component. I'm going to go ahead and just reset this.
All the blinky LEDs.
You know, find the next components you want. Like in my case, RCL. RCL is an important library. It contains all the passives, resistors, capacitors, inductors. So it's one to be aware of. And now I can go ahead and put in some resistors. Let's say I want some surface mount 0805s. I can put in a few that I need. And then escape, and then repeat. So you can really do a lot of all your component placement almost in one go. So one thing I do want to add is a frame. We have the frames library just to kind of define our work area. I'll pick a letter in a landscape. So letter size paper, landscape orientation. I hit OK. I put this here, and there we go. Okay, now obviously there's a lot of stuff here I don't need, so I'm going to go ahead and delete that. Now you'll notice the group command is active by default, so you can go ahead and just select whatever you want to get rid of. You select it, and if I press the delete key, it's gone. Okay. Now right here, I can move everything just by holding the left click and dragging. So I left click, I hold, and now I drag, and I can bring them where I want them to be. Okay. And you can do the same thing with the group. If you're new to Eagle, this may feel very natural to you because this is how a lot of applications work. If you're an older user or you've been working with Eagle for a while, this is probably going to seem very new. Okay, but that's a big functionality increase there in Eagle. So now to connect things, I'm going to go ahead and drag. Now, while dragging, you right-click, you'll rotate. Okay. I'm going to put this one over here. And I think that's everything. I actually don't think I need any more of these. So I'll go ahead and delete this one. Now I'm only starting with the subset again because of time. We're not going to do everything manually here, but I'm going to show the main operations. So to connect components in Eagle, what you want to use is the net command, okay? Do not use wire. I'm sorry, line. Line is for drawing.
Neither wire, if you type it or not. Don't just use net for
Net.
connections, period.
Net. Okay. So we click on net. You'll notice as you get close to a pin, to a valid start point, the little circle appears. Once it appears, if you left click, you'll start drawing the net. While routing, if you right click, you can change the bend style. Okay. So, and again, now once you get close to a valid connection point, you can left click and it'll snap.
Now,
Okay.
just in case, you'll notice that when he's running the net, it looks yellow and it goes green when it finished. It's only because he's using kind of a high resolution mode right now.
Yeah. Let them know.
Commonly, if you haven't changed your settings, it'll go from like a highlighted green to a dull green.
Yeah.
Between the greens. So that's the only reason you see it a little differently on his demo.
Okay. Now, let's say I want to connect to this net over here. This is where that 0.1 inch grid becomes important. Okay, because you don't get a snap point to a net. You only get a snap point between pins. Okay, so that's where you can get into trouble if you deviate from the 0.1 inch grid. Notice that I keep harping on this. This is important. 0.1 inch grid on the schematic. So I left click. When I left click on the intersection, you automatically get the dot. Okay, so you never have to place a dot yourself. Okay, so if you find yourself wanting to place a dot manually, you're doing something wrong, because the net command will place them automatically for you.
It's quite possible you're off grid.
Right.
That's why the grid is so important on the schematic editor.
Okay, so a couple of things I want to show while we're here. If we use the name command, you can change the reference designator of a resistor. So this one's R3. You can name it to something else. If we use value, we can assign a value to it. So like 120 ohms. Okay, and I apparently have my caps lock on, so sorry about that. Okay, 450K, etc. Now, a couple of things we can do. You'll notice that the command stays active, and that's key to Eagle. Okay, you select what you want to do first, and then the components you want to do it on. So again, I'm still on value. I can assign more values here. Okay, the command stays active. It'll stay active until I hit escape. So now I hit escape, and we're back to group. So a couple of normal operations. You can select the whole group. You can drag it around. Right-click to rotate. Okay. If you have a scroll wheel, which we highly recommend working with a mouse that has a scroll wheel, you can click it like a button, and it'll mirror, as you can see. Okay. Now, in the schematic, it'll do a mirror like you expect, basically the mirror image. On the board, mirror carries a different meaning, so we'll be talking about that once we get to the board. So I'll put that there. Okay. So what we're going to do now is I'm going to go ahead and bring in a design block just to kind of do the cooking show thing and finish off the rest of the schematic. Okay, so I'm going to select this. Ed, is there anything that I should address?
No, nothing. I've been able to.
Okay, so design blocks. I'm going to bring in my 555 timer. I'm only going to bring in the schematic for now. That way we can play with the board. Okay, now when using a design block, what we see is that if there's any existing nets, they need to be renamed. In this case, I have an empty schematic, so it's not a problem. I'll hit OK. And there we are.
Yeah, you would have seen regularly like 2 sets of names, but in this case, you only see 1 set because there's nothing there.
Okay. The only thing I do want to mention here is the supply symbols, okay, because that we didn't do before I brought in the cook schematic. Okay, design symbols are special. If you notice here, we have 1, 2, 3, 4, 5. We have 5 grounds. Okay. Supply symbols automatically connect to each other, even if you don't draw a net from one to each other, okay? One to the other. So these 5 grounds, by virtue of being supply symbols, they're automatically connected. Same thing happens with the plus 5Vs. These 3 are automatically connected. I don't have to draw nets between them to connect them. And what that allows you to do is to have a very readable schematic. It makes it easier to read because you don't have a lot of lines overlapping each other. So like in this design, you only have two main nets that overlap, which is this one, and really there's no way around it, and this one here. Okay? And you can tell that they're not connecting even though they intersect because there's no dot. Okay, if there's no dot, they don't connect. That's how you can tell. The supply symbols you'll find in the supply 1 and supply 2 libraries. Okay, they're over here. Supply 1, supply 2. Key point when using them. Okay, the net that they connect to is defined by the device name. Okay, so you'll notice we have a whole bunch for different voltage rails. If you come here and you change the name of this, it will do nothing. That's a common mistake that a lot of users make, and understandably so. If you go to name, you'll see that its name has no, sorry, not name, value. See how it has no value? Do you want to change it anyway? If you go and you change this, it will do absolutely nothing. It will still be connected to plus 5V. So keep that in mind with supply symbols. The net that they connect to, the net that they define, is whatever net name they have here. Is whatever the device name is here, okay? So that covers the schematic. Now we're going to go ahead and jump to the board. Ed, anything I should address before we go to the board?
No, not really. No, we're good.
Okay. So we're going to go ahead and click on board. I'm actually going to save this before. Call it demo.
So basically, we use the add command to acquire our frame. We use the add command again to acquire our components. And we use the net command to define our connections. At all the time, we will always work on the default grid, which is 0.1 inches. So component placement and defining connections, it's best to always work on a 0.1 inch grid, okay? Now, if there's any graphical elements on your board, on your schematic that you need, and you need a smaller resolution, it's okay to switch to grid temporarily for that instance only for graphical purposes. But anything else, go back to the default grid, please. That's it.
Okay, cool. So now we're going to generate a board from the schematic. We click over here. Says, doesn't exist. Do you want to create it? We say yes. And now we'll get a board. Now, major important key thing to keep in mind here. Okay. Notice that we have the green lightning that I was mentioning. That means forward and backward annotation is active. It is key, once you have a board, that the schematic and board are always open together. You can minimize. I can minimize the schematic if I want. But under no circumstance should you close it and then continue working, because what's going to happen is at that point, Eagle can't track changes from one to the other, and you'll break consistency. And that will make your life very difficult. That is... I think we can literally say the worst thing that can happen in Eagle is for you to break consistency.
Yeah, you want to avoid that.
Yeah.
You want to avoid that as much as possible.
If you catch it, if you realize it quickly, it's not too bad to recover from it, but you don't want to be figuring out that you broke consistency 3 hours ago, And
a lot of times when it happens is that by mistake you closed the board and worked on the schematic, so the board couldn't catch up. But Eagle actually does a really good job letting you know what you have when you have done that.
Yes, and let's show that. Okay, so right now I close the board. I say, I should have saved it.
No, don't save it. No, don't save it.
Say no.
Say no.
Okay, I go back to the schematic, and now I get forward and backward annotation has been severed. So Eagle immediately lets you know, hey, stop what you're doing, get it back. And all you do is you go here. I hadn't saved it, so I got to create it again. Remember?
Mm-hmm.
Now it's okay. All right. So Eagle will let you know. Eagle will pull up that banner saying, hey, stop it. But still, if you're working with the version of Eagle prior to that warning being put in, it actually would happen somewhat frequently. It would make our lives as support difficult.
Mm-hmm.
Okay, so now we're in the board. You'll notice that the key major difference between the board and the schematic is the existence of the design manager. Okay, now this is an extremely powerful feature. We're not going to talk too much about it here, but basically it allows you to very quickly analyze any element in your design. So you can analyze the signals, or the devices. If I click on a device, you'll notice that it will show you everything that makes up that device. Every line, every pad. It'll give you dimensions for the pads, you know, roundness factor, where they're located precisely. So you can get a lot of information from the design manager. It's really nice for making groups. So like if I pick these four objects, they're already formed as a group, so I can drag them, you know. So its biggest strength right now, in its current functionality, we do intend to add more to it. One of its biggest strengths is that ability to make very finely tuned groups. Okay. So what we're going to do now is I'm just going to go ahead and take these components, bring them into the design. Okay. And what I'm going to do is I'm going to drag this outline. Now, one thing you're going to notice is a difference in color. The inside of the board is black, whereas the outside is like this dark gray. This is the board detect feature. It basically recognizes that this is a board outline, and it accepts it as a valid outline. And this becomes important if you're going to work with Fusion 360, which again is for another video. So I'm going to go ahead and shrink this. Okay, cool. So now what we're going to do is we're going to go ahead and show a couple of things that are unique to the board that were not on the schematic. First off,
before you go there, Jorge, I just want to let people know that the way you move the parts was because since the group command is always active in Eagle by default, the only thing you need to do is click and hold, do a left click and hold on the origin of the component. That way you can move it. Because I wasn't sure if they were aware that they could do that without having to hit the move command.
Yeah, we touched on it in the schematic part.
Okay, very well. Okay, so as long as you hit that origin of the component with the group move, with the move command active, you could just click and drag the components. Okay, very well. Sorry about that, Jorge.
Yeah. So key thing to remember now here as far as the difference is the mirror command. Remember that in the schematic, mirror does a graphical mirror, but on the board it actually has a very important function. So we can click here on the mirror command. I'll click on this capacitor and you'll notice that the text reverses, which means it's on the bottom of the board, and the color changes. Okay, and again, mirror is still active, so I can move whatever I need to move to the bottom just by left clicking, okay? And I can move it back just by left clicking again. Okay, now why does the text reverse? The text reverses because in Eagle, you're always, your default view is top of the board. You're looking at the board from the top with X-ray vision. Okay, top of the board with X-ray vision. So if you have X-ray vision, any text on the bottom would appear reversed like it is here. Okay, so that's a giveaway that your board, that your component is on the bottom. And it's really necessary when you're dealing with through-hole parts, because with through-hole parts, if you do that, there's no color change on the through-hole parts. So we rely on the text to let us know that, oh, it's on the bottom. Now, you'll also notice that you have these yellow air wires. These are all the nets that were defined in the schematic. So you don't have to go and rack your brain trying to figure out what pad connects to what. That's already been taken care of for you. So here, the only thing you have to worry about is converting these air wires to copper. Okay, these are your guides. They're not copper yet. So you can't manufacture the PCB as it is right now. So let's go ahead and use the route command. And the route command is an extremely powerful command. It has lots of options. We're going to only cover a very small subset now, just to highlight the basic routing mechanism. Okay, so I'm going to go ahead and click here, and you notice that the route starts. Okay, the default width is defined by your DRC and your net classes. So that's what it's going to go with by default. And I can take it. Once I reach the end, if I left click, now by default we have a beep. So when you're routing, if you hear a beep at the end, that means you made a proper connection. Just go across, beep.
And it automatically disconnects from your mouse cursor as well.
Correct. So you can keep routing the next one. Now here, we have this connection that's on the bottom layer because it starts from that pad. Now what happens if we want to finish it on the top? So let's say we go over here. Now notice that by default, it's not going to allow you to short anything out. So it's going to walk around any obstacles in the way. And that's a very handy feature. So it can make it very easy to route. There's also a pushing feature. But again, that's beyond the scope of this webinar. So let's say we want to go ahead and connect to the top. Easiest way to do it is if you hit spacebar, you notice that a via appears. And at the bottom over here, it tells us that the next layer is going to be top. So if you have a multi-layer board, if you continue to hit spacebar, you'll cycle through the various layers. But because this is a 2-layer board, then it's just going to go straight to top. So once I left-click to place the via, now I'm on the top, and I can left-click to finish the trace. Okay? Now there's other tools we can use to speed this up. So if you look here, we have some quick route tools. These help us to quickly and very efficiently route signals that manually would just take up time. So I'll go ahead and go over here. You can do it AirWire basis or the whole signal. So I can go over here, I can just start clicking, and you'll see that it's going to try to route everything as best as it can.
Yeah, it's a pretty powerful tool. Also lets you do multiple lines if you wanted to.
Yep. But again, that's for another webinar.
Don't confuse this with the auto router. This is not the auto router. This is quick
Correct.
route. This is part of the manual routing features.
Mm-hmm. So if we look here, it wasn't able to make this one. So this one we would route manually. Now, if you decide you want to rip everything up or you want to undo a trace because you're not happy with it, rip up is a command to do this. Rip up converts the trace back to its AirWire form. And that way you can reroute it and go in a different direction if you want to. Okay. The default mode is basically one segment at a time. You can do all connected copper. So here it'll do the whole thing, including any vias that are along the way. You can do connected copper that's on the same layer. So like if I do this one and I click here, it'll leave anything that's on the top. So it'll leave this via and this trace because only the bottom is on the, as you can see right there. And it's stopped here at a pad.
Yeah, always stop at the connecting point.
It'll always stop at a pad. It won't continue past one. Okay? So, and then finally, if you just want to rip everything up, you can click here, clean everything out. Now we're back to all AirWires. Now, one thing that's really important is that you generally don't want to just have traces. For grounding and shielding reasons, you'll want to have a polygon. So we'll go ahead and create a polygon along the top. Okay, it'll ask for a name. I'll call it ground. Say OK. Now, if I have it fill in, everything that's connected to ground will connect. Okay. Now, visibly, this can be a little jarring because when you start to route, it doesn't automatically update because that takes up a lot of resources on a big board. So what you can do is if you just want to undo the fill, you go to rip up and you have rip up polygons. And it'll put it back to AirWire form. Okay. To fill it in, you just click Rat's Nest. So Rat's Nest fills it, rip up polygons unfills it. Rat's Nest also recalculates the AirWire so that they're straight lines, shortest distance straight lines. So we're going to take advantage of now is we're going to go ahead and run the auto router just so you guys get an idea of how that works. So I'm going to click over here, auto router. The auto router basically will run multiple variations depending on how many cores you have. This is a 4-core machine if memory serves, so it can run 2 per core. So I'll go ahead and leave the effort low, that way I don't make so many variations. The auto grid selection basically defines a fine grid, and top router is the topological router. We could spend a whole webinar talking about the auto router, but basically all you want to keep track of is that the layers you have available have a preferred direction set. Auto is the default. You're going to continue. And we'll see this is going to create 5 different routing variations. So I'll hit start. Okay, and you can see it was pretty quick. They all made it to 100%. You can see they're all slightly different. So in a case like this, you just pick whichever one you like best. I'll click End Job here. Now, one thing you may notice is that the polygon, part of the polygon clears up. You can just clean it up by hitting Rasmus or recalculate. You also want to make sure that the polygon didn't break, that there's no air wires left anywhere. And Rasmus will let you know. If there's any air wires, it'll say, however many air wires are remaining. But in this case, everything went perfectly, so nothing to do. Now, why could you still have an air wire after the auto router says 100%? If the board is particularly dense, the traces, if you notice, they cut into the polygon. And if they cut in enough and in the right places, you'll get these isolated islands of copper that don't connect to the entire ground plane. In those situations, once you run the rat's nest, Eagle will catch that you have those islands, and it will draw air wires between them. And that's how, even though when the auto router runs, it initially has 100%, you may still end up with slightly less afterwards, because if the polygons break up, then you'll get those air wires. Any questions on this, Ed? Anything we need to address before I go to the cam?
No, we'll go back to the polygon.
Okay. So at this point, what we're going to do is we're going to talk about the CAM processor, which is generating the manufacturing data. So there's 2 ways to do it. First is this one, which is the one-click way. It's going to ask you to save. The CAM processor always wants to work on the latest version of the design. So yes, we'll save. Okay, and the one-click basically gives you a little summary of what is produced. It uses a template file. It basically looks at the number of layers that have been defined, in this case 2 layers, and then it automatically produces the Gerbers for it. So if you have a simple 2-layer board or even a 4-layer board, and you don't have any special requirements, like you don't have any slots, then this will work just fine. It'll generate all your files, and it'll save them to a zip location. By default, it'll be the location of the design, and I'll hit save, and bam, I have my Gerbers. And it even opens, and there they are. My Gerbers are right there. All my manufacturing data, my Gerbers, my Exelon are there. Now, if you do need something more specialized, you click here, and this allows you full control over the CAM processor. So again, it will upload the 2-layer CAM job, so you can see, you can get a preview of what each file contains. You can see what layers are contained. 16, 17, and 18. Profile is just a board outline. What the solder mask is. Solder paste, silkscreen bottom, etc. Okay, you can set up, this is your Exelon, this is the draw file. You can control the format of both types of files, where they go. You can save the path to different locations. There's a lot of control that you have here. You can make it export a DXF. You can make it do many, many things. So there's a lot of power here. So you will have full control if that's what you need. But if you're getting started, we recommend start with a simple 2-layer board. 2, 4 layers, no slots, nothing that requires special layers, because it won't automatically pick up any special layer definitions. It'll just go with defaults. When you set it up, when you start off, if you need to do something special, then you have to go into here and make the adjustments. And if I hit process job, it would do the same thing as before. You can see the checkboxes. Now, one thing that's cool here, if your manufacturer has a CAM job with us already, so if you go over here, you can go third party. You'll see that we have several. We have Beta Layout, Oshpark, Seed, Iser. So if you like Oshpark, you upload their CAM job, and you'll see everything is set up according to their specifications.
Yeah, these are specifications they've provided us, and we just added it to Eagle.
Correct. So you can see, really useful, really powerful. So what we're going to do now is I created the Gerbers, and there's one thing actually I want to highlight before we go check them out. Okay? Or actually, let's go check them out, since it'll become obvious once we do. Key point for everyone. Okay? When you're working with Gerbers, once you generate them, it's always a good idea to view them in a Gerber Viewer before you send them out to the board house. Doesn't matter what the Gerber Viewer is. You can use GerbV, you can use ViewMate, you can use GC Preview, CircuitPeople.com, whatever. It's always a good idea to verify the Gerbers through a third party, because no one's perfect, right? Maybe you made an error setting up the cam job. You know, you just want to have that extra verification, because in the end, you're responsible for the product. Board houses won't take responsibility for any issues in the design, neither will we. So the responsibility falls upon the designer to verify that the cam data is correct, is what they expected, before they send it off to the manufacturer. So that's just a word to the wise. So I like to use ViewMate here in the office. I've been using it for many years, since before I worked here at CADSoft, CADSoft, at Autodesk.
I haven't heard that in a long time.
Since before I worked here at Autodesk. So I've been using it for a really long time. I trust it pretty much blindly at this point. I've never had any issues with it. So definitely that's the one I recommend, but you can use GerbV. GerbV is very good. I did run into a bug with GerbV a few years ago, so that's why I don't trust it as highly as I do ViewMate, but it's still a very good piece of software. So pick a Gerber Viewer, learn to use it. In our cases, you don't have to learn to do very, very fancy things with it. Just know how to import your Gerbers. So what I'm going to do is I'm going to go File, Import. I'm going to pick Zip, because that's what we used. I'm going to go over here to Documents, Eagle, Projects.
Now, you don't need a Gerber Viewer with editing capabilities, okay? There's no need to spend money on the editing capabilities, because you don't want to edit your Gerber files. If you're going to edit anything, you want to edit it in Eagle, okay? So basically, you only is really looking for is a viewer. That's it.
Mm-hmm. So you can see it will go ahead and import everything like it did in this case. It recognized them, recognize the units. All right, I'll click OK. And there we go. Okay, we can turn off layers as we see fit. So I'll go over here, turn that one off. Those are the drill layers. Copper. Let's turn off some of the copper. That way the polygon isn't there.
Yeah, there you go. Yeah, that's the best. Yeah.
Okay. And now we can see the text. Now, one thing that may stand out is that this text looks very different than what's on the board in Eagle. Okay, I'm going to go ahead and.
That's kind of funny.
Right? You can see this is not the same. Okay, before, after, before and after. Now, why is this? So the Gerber standard only recognizes vector fonts. It doesn't recognize any TrueType font. Basically, when a PCB, if you notice a PCB has any fancy text or any fancy silkscreen on it, they've either vectorized the font or they've imported that text as an image, because the Gerber standard on its own doesn't accept anything other than a vector style font. So what ends up happening is, if you use the default in Eagle here, which is a proportional font, right? If we go to the properties, you'll see the font is proportional. Then when the Gerbers get processed, proportional gets turned into vector automatically. Now with the new vector font we have, there isn't that big a size difference, but the old vector font was actually like 15 to 20% wider. So what would happen is sometimes text would run off the board. But our new vector font doesn't have that problem. In fact, I think it's actually a little bit thinner. It actually ends up thinning out a little bit, relative to proportional. So that problem has been fixed. But just keep that in mind. The reason it changes is because of that. Now, if you decide, like many users like, that they just want to see it as it's going to be on the board, then you have a few options. You can go to Options, User Interface, and you can say Always Vector Font. And you'll see that everything looks vector, as it is going to be manufactured. My only beef with this setting is that it's purely aesthetic. If you go to the info command, it still says it's proportional. So that can be confusing. So I don't tend to like that setting, but some users do. So I make you aware of it.
I got some questions.
Mm-hmm.
Do you want to go ahead and finish up? That way we can start the Q&A.
Yep, I'm going to finish up right now. So just to show how you can set everything to be vector font, you just basically group everything. You go over here to the change command, which is the wrench. You select font, vector, and then to apply the action to the group, hold down Control and right click. And you'll see that everything changes. Okay? And in that case, it really is set to vector. And
You
I prefer
press and hold the control button and then right click.
right click.
You know, okay, you press and hold the control button.
And that's the same with all group operations. All group operations work the same. You select what you want to do, control right click to do it on the group. If you just left click, it'll do it on that one item. And just for those of you who maybe saw, change is extremely powerful and it's used for modifying. It is Eagle's main modifier. You can change pretty much everything through the change command. So let's go to questions, Ed.
Okay, yeah, I got a whole bunch of questions, and the idea is to answer all of your questions. I just wanted to get through the information first for the recording purposes. Well, thank you, everybody. Have a great day. It's been a pleasure.
Bye, everyone.